Hello, in this video we're going to be taking a look at straight line graphs. Now this is something you'll probably be familiar with already from GCSE maths, but it's going to come up again in A level, so it's going to be important to know, how to sketch straight line graphs, how to find their equations, and just have some general information about them, which hopefully this video is going to help with. So we'll start off with the sort of general equation of a straight line, and that's going to be given by y equals mx plus c. Now all of you should have come across this equation already in GCSE maths, but just to quickly go through it, the letter m is going to represent the gradient of our straight line, okay, and that just means sort of how steep our straight line is, or what the slope is of our straight line, and we're going to look at how we can calculate that in a second. But first let's see what it means graphically. So say we have a positive gradient, and by that I mean the value of m is a positive number. Then when we plot our straight line or sketch it, it's going to be sort of a line that looks like this. Okay, it's going to be uphill, and that means we have a positive gradient. Okay, and so the greater that positive value, the steeper our slope is going to be. Okay, now say our value of m was negative, we had a negative gradient. Well, what that means graphically is that our straight line graph is going to be going downhill, so it's going to be looking sort of something like this, and this would represent a negative gradient. Okay, now the letter c on the end, this represents the y-intercept. Okay, and what that means is where our straight line graph is going to pass through the y-axis. So say our straight line in the red, say it passes through the y-axis at the point y equals, say, 10. Well, in the equation of that red straight line, then the value of c would be equal to 10. So I think that's pretty easy, right? So now let's take a look at how we can sketch a straight line graph given an equation. So you can see here we need to sketch y equals 2x plus 3. And so immediately we know the gradient of this line is 2, and the y-intercept of this line is equal to 3. Okay, so in GCSE maths you might have drawn a sketch or plotted this graph by doing a table of values. So you might have had x and y values like so, and I'll just draw a little sort of table like this. So you might have had, say -1, 0 and 1, and you'd substitute each value of x into the equation, get a corresponding value of y. So for example, if we substitute in x equals -1, we would get 2 lots of -1 is equal to -2. Plus 3 gives us +1. So now we've got a coordinate. We know when x is equal to -1, y is equal to +1. And we could plot that then on our graph and plot all of these points and draw a line connecting them all. But that's quite a long sort of process just to draw a straight line graph, because to draw one, we only really need to find 2 points that lie on the line. And so in A-level maths, the sort of general way we're going to do this is by seeing where the graph cuts through the x and y axes. Okay, so let's start off with the easiest one, which is where it cuts through the y-axis. And so for this straight line equation we've been given here, we can immediately see it's when y is equal to 3 because of our value of the plus c, our constant on the end. So it's going to be at this point here. Now sometimes your line won't be in a form y equals mx plus c, okay, and if that's the case, all you need to do is substitute x equals 0 into your equation of your line. And the way this works is, well, if x is equal to 0, then our line is going to be on the y-axis somewhere. Okay, so we could do that now. If we substitute in x equals 0, we've got y is equal to 2 times 0, which is 0, plus 3, and so we get y is equal to 3, which checks out, it makes sense. And we can apply the same logic to find out where it passes through the x-axis, because it's going to be on the x-axis when y is equal to 0, because when y is equal to 0, so you can kind of see, I don't know if this makes sense, hopefully it does, our line is going to be somewhere on the x-axis. And so we can say when y is equal to 0, we have 0 is equal to 2 times x plus 3. And so now if we rearrange to make x the subject, this will tell us where our line passes through the x-axis. So subtract 3 from both sides, -3 is equal to 2x, and divide both sides by 2, we get -3 over 2 is equal to x. And so we know it passes through the x-axis at the point x equals at least -1.5, so this point here. So now we've got these 2 points, I can just connect them with a straight line like so, and if I do that, I've drawn a nice sketch of my line, y equals 2x plus 3. Now an alternative way you could do it would be, say, well, we know the gradient is 2, and so what that means is kind of for every 1 unit across we go in the x-axis, we're going to go up by 2 units. And so once we found one point, say the y-intercept, so this point here that in the red circle I've just gone over again, we could say, well, we're going to go across 1, and then we're going to go up 2 units, and that would give us a second point. However, in A-level maths, it's not very common to be given such a nice sort of equation of a line, so it's more useful to know this method. Okay, so now let's look at how we can find the equation when we've been given a line. So here you can see in red we've been given this line and an axis. So immediately we can see it cuts through the y-axis at the point 4. So we know our equation is going to be something like y equals mx plus 4, like this. So from here we need to find the gradient of our line, and there are a few ways you can do this. You could do it sort of how I said before. We could say, okay, so if we go across 1 unit, how far up or down do we go? So we go across 1, we then go up 3 units. So the gradient's going to be 3. However, it's rare in a question that you'll get something this nice. So there's another way we can do it, and it's using a formula for the gradient. And I'll show you what it is first. I'll sort of show it algebraically, and then I'll use it in this question, and hopefully it will make sense. So say we have 2 points that lie on the line, say a point x1, y1, and another coordinate x2, y2. Now these little numbers, we call these sort of subscript, they're just showing that this x1 is a different number to the x2, right? Hopefully that makes sense. So we've got these 2 points that lie on the line. x1, y1 is one coordinate, x2, y2 is the other. Now to find the gradient, that's just the difference in y divided by the difference in x. So the gradient m is going to be equal to y1 minus y2 divided by x1 minus x2. And it's important we do it in this order. So the best way to do it is to pick points on your line that have integer values. So by that I just mean coordinates with whole numbers. So let's pick a couple. Say this one here at the point 0, 4, and let's say this point up here with the coordinates 1, 7. So the gradient of this line, let me sort of make this a bit smaller and move it up here. So the gradient of this line is going to be equal to m, so the difference in y, so 7 subtract 4, divided by the difference in x, so that's just 1 subtract 0. Okay, and so simplifying this, we're going to get 3 over 1, which is equal to 3. And so we get that y is equal to 3x plus 4. And that would be the equation of this straight line in red. So I think that was also pretty easy. So the more generic sort of questions you're going to get in A-level maths are like this. So you'd be asked to find the equation of a straight line that passes through the points negative 1, 1 and 1, 5. And I've drawn this out sort of on a nice graph so you can visualize it, but in reality you'd probably just be asked the question. So that you couldn't use the fact that, well, I could see where it passes through the y-axis and then count 1 across and go up, right? So this is where it's more practical. So in one of these questions, what you're going to want to do first probably is find the gradient of your line. And remember, that's just the difference in y divided by the difference in x. So the gradient m is going to be equal to the difference in y, so 5 subtract 1, divided by the difference in x, so 1 subtract negative 1. And so this is going to give us 4 over 2, which gives us 2. So now we have the gradient of this line equaling 2. So we've got y is equal to 2x plus c. So from here we just need to find the value of c, which is our y-intercept. So how can we do that? Well, we know that both of these points lie on the line, which is really useful. So say we focus in on this one here, 1, 5. Well, if I substitute in those coordinates into this equation, okay, I could then rearrange to find c, because say I substitute in x equaling 1, I've got 2 times 1 plus c, and I know that if it lies on the line, that has to equal positive 5, okay? And so now we've got 2 plus c is equal to 5, so if I subtract 2 from both sides, we get c is equal to 3, and so I get that y is equal to 2x plus 3, and that is the equation of my line going between 2 points. Now, you can do it this way, that's a perfectly fine way to do it, but at A-level we use another formula, and I'm going to write down the formula, explain where it comes from, and then answer the same question again using it. So in A-level maths we use this formula here, y minus y1 is equal to m multiplied by x minus x1, where x1 and y1 are just a pair of coordinates on the line, and m is still our gradient. So where does this come from? Okay, so say we were asked the question, say we're given the gradient of a straight line is m, so we have m equaling, or the gradient of a line, gradient of line equals m, and we know that the point x1, y1 lies on our equation of a line, okay? With this information, could you find the equation of this straight line? Well, yeah, because we did it a second ago. We said we'll use the fact that y equals mx plus c and substitute in our points. So we would have that y1 is equal to m times x1 plus c, okay? Then from here we rearranged, didn't we, to make c the subject, because then we found what that constant on the end was. So let's subtract m times x1. So we've got y minus m times x1 is equal to c. And so from here we substituted the value of c back in to our equation of the line with our gradient. So we got that y is equal to m times x plus our constant. So y, whoops, sorry, that should be a y1, y1 minus m times x1. Now at the minute this looks confusing and it doesn't really look like the equation I wrote in red. But if I subtract y1 from both sides, then we get y minus y1 is equal to mx minus m times x1. And I could then factorize out the m from both sides and we get y minus y1 is equal to m multiplied by x minus x1. Okay, and you can see that all in one go what this new equation has done is it's substituted in the coordinates with the gradient to find the constant on the end. And it saves us from the two steps that we did before where we had to find the gradient, then write y equals the gradient times x plus c, substitute in some points, rearrange to find c, and then substitute that back in. Hopefully that makes sense. So I'll just basically demonstrate how to use this equation of a straight line, y minus y1 equals mx minus x1, and it will make a lot more sense because it's actually really easy. So we need to find the equation of a straight line that passes through the points negative 1, 1 and 1, 5. First step, find the gradient. So that's just the difference in y divided by the difference in x. So 5 subtract 1 over 1 subtract negative 1. So we're going to get 4 over 2, which is equal to 2, like before. Now, we just need to pick one set of coordinates. So I'll pick this one again because they're positive numbers. They'll be nicer to work with. So 1, 5. And let's substitute everything into this equation in red. So y minus our y coordinate, which is 5, is equal to our gradient multiplied by x minus our x coordinate, which is 1. So now expand and we get y minus 5 is equal to 2 times x minus 2. Let's now add 5 to both sides and we get y is equal to 2x plus 3. And you can see this equation is exactly the same as the one we got using our other method. Now this might seem confusing because I just explained where the formula comes from as well, but you can see in reality it's actually quite easy to use. So hopefully that makes sense. Let's now look at parallel lines, which are really easy. So one fact we need to know is parallel lines have an equal gradient, okay? And so you can see if I copy this line in red, now I've created another line with the same gradient. It's got a gradient of 2. And you can see it doesn't matter where I put it, so I'm just changing the value of c by moving it around. It doesn't matter where I put this line, it's going to be parallel to it. And the reason for that is it has an equal gradient. And we're going to use this fact to answer this question. So we need to find the equation of the line L that is parallel to y equals 2x plus 6 that passes through the point 1, 3. Immediately, because this line is going to be parallel, I know the gradient of line L is going to be equal to 2. Okay, so we can write that out. So the gradient is going to be equal to 2 because it's parallel, and it's going to pass through the point 1, 3. So we can use this new formula we looked at, y minus y1 is equal to m multiplied by x minus x1 to find the equation of this new parallel line. So we're going to get y minus 3 is equal to 2 lots of x minus 1. Let's expand and we get y minus 3 is equal to 2x minus 2. Adding 3 to both sides, we get y is equal to 2x plus 1. And that is the equation of the straight line that's parallel to y equals 2x plus 6 that passes through the point 1, 3. That's really easy. And the final thing we're going to look at is perpendicular lines. So lines are perpendicular to each other if they cross at a right angle or at 90 degrees. So for example, if I sort of sketch one random line on, these two lines are perpendicular if they cross at a right angle. And we also say these lines are normal to each other. So the black line would be the normal line to the line y equals 1/2 x plus 2. Now, perpendicular lines have a property where if you multiply their gradients together, it equals -1. Okay, and this is going to be really useful in answering this question. So find the equation of the line L that is perpendicular to y equals 1/2 x plus 2 that passes through the point 2, 3. So we know the gradient of this red line is 1/2. Okay, and so what that means, whatever the gradient of my perpendicular line is, let's call it m, if I multiply it by 1/2, it has to equal -1. And so from here I could just multiply both sides by 2, and that tells me that the gradient is equal to -2. So that was really easy. Now, in reality, you don't have to write this out every time. You can just use the fact that if two lines are perpendicular, the gradient, say the gradient is of one is 1/2. If we take the negative reciprocal of that, it gives us the gradient of the other. So by negative reciprocal, I mean we take the reciprocal of it, so we flip the numerator and the denominator, and we multiply it through by -1. So for example, if I gave you a line with the gradient -3, the gradient of the line perpendicular to it would be positive 1/3, because we take the negative reciprocal of -3. Hopefully that makes sense. So using that fact, we know the gradient of our perpendicular line is -2. We know it passes through the point 2, 3. So let's use our formula, y minus y1 is equal to m multiplied by x minus x1. Expand and we get y minus 3 is equal to -2x plus 4. And then we're going to add 3 to both sides and we get y is equal to -2x plus 7. And so if I wanted to sketch this graph, I know it passes through the y-axis, it's the point y equals 7, has a gradient of -2. So it's going to look something like this, and you can see it passes through the point to 3, which is here, and it's at a right angle to our line in red. So hopefully this video was useful. If it was, like, subscribe and share. I'll link my Preparing for A-Level Maths playlist in the video description, and if you've finished that, then you can go over to my YouTube channel for A-Level Maths tutorials. Thanks for watching.